Hi everyone, welcome to Integral Calculus. Today we explore lesson 8.2 and 10.2, area of a surface of revolution. Rotate the curve y equal fx around the x-axis as seen in this picture. Then we get a surface of revolution. We can find the area by cut out a sample surface. I'm going to do the cut in here. And so if you look at a sample surface, it does resemble a frustum. Oh, so what we need to do is that we got to figure out the surface area of a frustum, and we can add up a bunch of these samples at the limit as n go to infinity. And ta-da, we have the area of a surface of revolution. Okay, for a frustum, this is the frustum. We can extend the two side length, and if we do so, what do we have here? We have a cone. Yay. So first, let's take a look at the surface area of a cone. This length is L, and then this would be the smaller radius R. If we cut out this cone right here, then it's gonna fit onto a circle, and it's just a part of the circle. You're gonna have some area like this. This is the surface area of the cone here. I'm gonna call it S. The radius is L, and then this part right here, which is the circumference of the base of the cone, is exactly this arc length, 2 pi r. Oh, and then from here we see that the surface area is the fraction of the entire area. Okay, fraction theta, and this would be the angle theta right here, over 2 pi of its multiplication. The area is pi, radius is L, so pi L square, which simplify to 1/2 theta L square. Well, if you look at the cone, right, we don't have any angle theta, so it is best if we can figure a way to rewrite the angle theta. And to do that, well, we can use the fact that the arc length of a circle is a fraction of circumference. Arc length, well, 2 pi r is equal to a fraction theta over 2 pi of multiplication. Circumference is 2 pi multiplied to the radius L. Oh, beautiful. From here you see that 2 pi r is theta L. So theta is 2 pi r over L. And then now we can do the substitution to get the surface area to be 1 over 2 times 2 pi r over L times L square, which is pi r L. Surface area per cone. Now we're gonna take a look at how we compute the surface area of the frustum. Okay, it is the frustum right here. There are two radius, smaller one and the bigger one. I'm gonna call this the R and R1, R2. Okay, and this side length here is L. So we can extend it to get a cone, meaning that this side length is, you can call it L sub 1. So what we know here is that the surface area of a frustum is the surface area of the bigger cone minus the smaller cone. Is surface area of bigger cone minus surface area of smaller cone. I'm gonna write it. Area of bit cone minus area of small cone. The area of the big cone, we use the formula, then it would be a pi radius r sub 2 and the side length is L plus L1. The area of a smaller cone is pi r sub 1 multiplied to L1. Okay, distribute, so pi r2L plus pi r2 L1 minus pi r1 L1. We can get the L together. So we have a pi r2L plus pi r2 minus pi r1 L1. And I can factor out the pi here, just make it a little easier to see. R2L plus R2 minus R1 L1. Yay! Well, in the frustum, we don't have L sub 1, so we'll have to do some kind of substitution. We can draw a straight line here, and we say that, oh, there are two right triangle, this one and the bigger one. Use similar triangle. Similar triangle tell us that L1 over R1 is L plus L1 over R2. So do the cross multiplication. L1 R2 is LR1 plus L1 R1. So I'm going to get out the L sub 1 on one side LR1 is L1R2 minus L1R1. And then we say that LR sub 1 is L1R2 minus R1. Hey, how nice. This one can use the sub from the similar triangle. And we have pi R2L plus R1L. So this would be pi R1 plus R2L. R1 plus R2 is around, it's the average, right, of the middle one. So this line right here would be half of R1 plus R2. So now I'm going to do a trick here, and I'm going to let that to be the radius R. Okay. So what we have is pi multiplied by 2 times half of R1 plus R2 times L, which is 2 pi R L. Area by surface of revolution is S, and it would be limit n go to infinity of the Riemann sum equal 1 to n of a bunch area of Frustum. The limit of the Riemann sum is the integral over the curve C of 2 pi R L. If we rotate about the x-axis, then we have integral from A to B 2 pi y root of f prime x square plus 1 dx. And if we rotate about the y-axis, then it would be from C to D 2 pi x root of g prime y square plus 1 dy. In case we parameterize the curve, then the integral is going to be from alpha to beta 2 pi y root of dx over dt square plus dy over dt square dt. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.